Hello, my name is Daniel, and today I'm going to be covering chapter 11.2, which is on series. So the primary objectives for this lesson are going to be one, determine what exactly is a series, and number two, define geometric and arithmetic series, which are the most common type, and number three, finally, to discuss divergence and convergence of series. Let's get started. So a series is really just a sum. What does that mean? Well, it's related to a sequence. So the series of a sequence is just the sum of some amount of terms from that sequence. For example, if I have the sequence a sub n equals n over n plus 1, and I wanted to find the series, that would just be the sum of a sub n, or the sum of n over n plus 1. The most common types of series are geometric series and arithmetic series, which are defined based on a geometric sequence or an arithmetic sequence. Other types of series include harmonic series, or really they can just be of anything as long as it has a defined sequence that goes along with it. So arithmetic series, there's some nice properties of them, and we can derive all these by looking at an arithmetic sequence. An arithmetic sequence looks like this. So the nth term is the first term plus the common difference times n minus 1. So for example, my arithmetic sequence looks like this. A plus D, A plus 2D, A plus 3D, etc. And it goes all the way to infinity. So let's say I wanted to find the sum, of the first n terms. So we denote that as S of n. So that's just the sum from the first term to the nth term of this sequence. If we look at it, there's a formula. It says that the sum is the first term plus the last term all over 2, and then times the number of terms n. And this is true because, well, if you look at this, this is the number of terms, and this is just the average of the terms, and the average times the number of terms gives you the whole sum. Another way to think about this being the average is the first term, a sub 1, is a plus d times 1 minus 1, or just a, and a sub n is a plus d times n minus 1. Which is just a plus d times n minus 1 over 2. And this is the middle term of that arithmetic sequence. So that's why that gives you the sum of the arithmetic series. So let's do an example question. Let's say I want to find the sum from 1 plus 3 plus 5 all the way to 13. Well, let's just find our values and plug them in. A is 1. The common difference is 3 minus 1, which is between two adjacent terms, or 2. So let's plug that in. We need to find the number of terms in here. But we know what that is, right? A sub n is 13, which is a plus d times n minus 1, which is 1 plus 2 times n minus 1. So solving for n, we can subtract 1 from both sides, and divide by 2, and then add 1 back on, so we get 7 equals n. This should be a minus, sorry. Okay, so now we have everything, we plug it in. S sub n is just S sub 7, which is the first term plus the last term divided by 2 times the number of terms, 49. Okay, the other type of series is geometric series. Geometric series are related to geometric sequences. Geometric sequences are the nth term is the first term times the common ratio to the n minus 1th power. Okay, let's look at this. this means that the sum of the first n terms is a times r to the 0 plus a times r to the 1 plus a times r squared all the way to a times r to the n minus 1. If we multiply this by r, let's see what happens. The sum times r is a times r, or ar, plus ar times r, or ar squared, all the way to ar to the n minus 1 times r, or ar to the n. Now look, these look pretty similar. If you notice, these terms match up. So if we subtract, they should cancel out. So the nth sum times r minus 1 is just a times r to the n minus 1. So the nth sum is a times r to the n minus 1, all divided by r minus 1. Okay. Now, what's interesting is if the absolute value of r is greater than or equal to 1, okay, then what's going to happen to this? This is going to go to infinity. So the sum is going to go to infinity or diverge. It's not going to go to a set value. On the other hand, if the absolute value of r is less than 1, then as n goes to infinity, this value gets smaller and smaller and eventually goes to 0. So instead, we can write the total sum is negative a over r minus 1, or a over 1 minus r. So this is the formula for sum of an infinite geometric series which has common ratio less than 1. Let's do a sample problem. Find the sum of the following series: 3 minus 2 over 3 plus 4 over 27 minus 8 over 243, etc., etc., etc. So a is the first term, which is 3, and r is the common ratio, or negative 2 over 9, since each time I'm multiplying by negative 2 over 9 to get to the next term. Thus, plugging into our formula, s equals a over 1 minus r, which is just 3 over 1 minus negative 2 over 9, which is 27 over 11. That's the sum. Okay, finally, I'm going to address convergence and divergence. So divergence is when the sum of a series does not approach a set value. So doesn't go to a single value. What does this mean? It can go to infinity, it can go to negative infinity, or it can just alternate. For example, the sum of negative 1 to the n also diverges, because this is just going to be negative 1 plus 1 minus 1 plus 1, and this doesn't go to negative 1 or 0. It switches back and forth between the two. So we don't know what it goes to. Similarly, we can, so the reason we say this diverges is by the divergence test. Divergence test says that if the limit as n goes to infinity of the nth term in the sequence is not 0, that means you're still adding on values even as you go to infinity. So that means that it cannot possibly converge to a single value. It has to, it's still changing even as you get to infinity. If the infinity term goes to 0, that doesn't necessarily mean that it converges. For example, a classic, the harmonic series, which is thus the sum of 1 over n, this diverges. And a quick way of looking at that is, well, we can split it by powers of 2. So we look at we look at 1, then we look at 1 over 2 plus 1 over 3, then we look at 1 over 4 plus 1 over 5 plus all the way to 1 over 7. And look, each of these is going to be bigger than 1/2, right? This is obviously bigger than 1/2. This is 4 things that are all bigger than 1/8. So those are all bigger than 1/2. 1/8 all the way to 1 over 15. Those are all 8 things that are bigger than 1 over 16. So their sum is going to be bigger than 1/2. And this goes to infinity. And since you're adding up an infinite amount of 1/2s, you're going to reach infinity. So not all sums go to infinity. So you can always test for convergence using tests like the ratio test or the integral test, which are explained in other videos in more depth. So I hope you learned something. Thank you.